everyone, today I'll be doing the Div 4 Codeforces contest. Let's see, okay. Enter. Okay, let's see how long it loads. 2 digits to make a sum greater than Python input dot split a dot sort. Okay, I'll submit that. Hopefully it submits correctly. Come on, tell me it's submitting. Okay. Okay, for each test case, there's a number of responses. Input okay, for line range 1 plus 1 ABS. BI. Okay, let's submit that. Oh my god, it took more than a minute just because it took so long to load the submissions page. That's not fair. Lost. Okay, let's get the input. SCC. Okay, submit that. Okay, I'm just really annoyed. I'm really annoyed that my problem A took like over a minute to submit, considering I submitted it with like actually like 20 seconds spare. Why am I getting Cloudflare? Is it submitting or not? Problem is I don't want to make multiple submissions. Why isn't it submitting? Like this is actually like annoying me. Is submitting? Hello? Hello? Why isn't CF submit working? Do I make a manual submission? Okay, this is annoying me. I guess I just have to submit myself. Wow, thank you. Okay. Okay, if m Okay, submit. Oh no, that doesn't work. CF submit just isn't working for some reason. Okay, at that time it worked. See, that just annoys me. Like, sometimes it just doesn't submit properly. How many problems are there? HSW. Okay, this could just be like a binary search problem, it looks like. Or maybe not even binary search, it could just be math. Yeah, we're just gonna use C++ just so that just to make sure it's fast enough. Hi is equal to. It's just an element. Okay, currently 0 for if current is greater than okay, let's see how this does. Failed. Oh, I misunderstood this problem. Okay, let's see. Times mid times. Okay, I plus 2 times mid then. I misread that problem. Okay, we're gonna use Python. Sorry, I totally misread that problem. We're gonna use Python now. That was my bad. Okay. I guess the sum of s times 4. Oh. Oh my god, I'm totally misunderstanding this problem. Yeah, I misunderstood that problem totally. I'm trying to work out what the maximum bounds is. Okay, we can go with high as 189. That should be fine. Okay, that was super slow because I misread that problem like so many times. Unexpected error. I got an unexpected error, so I guess I'm going to submit manually. Submit. How do I submit? I hate how it's not working properly today. Okay, I see. This problem is actually quite annoying. Okay, I see. This should be fine. I can't this one. Okay, that was easy. Okay. Okay, there's 8 directions. How many ways can you put a compass at one part and the What? Oh, I see. Like, how many points are like... Okay, let's go. Scanner. Read in 2 numbers. I guess AX, BY. Is it answer times 2? Yep. Submit that. This is the last problem, I believe. Okay. Should be, so there's DI meters in front. What does partition really mean? I mean, this is really just like a DFS. Okay. I'm not gonna worry about stuff too much. What's the max number? It is 200,005. Okay, let's false and okay, we're gonna add in some edges to my graph. This will all make sense later when I explain it, but it's actually a very common idea. Okay. Wow, no debugging for that either. Okay, all of my problems are in. I was really annoyed that I'm going to get an extra penalty because it took so long forever to submit. So I should have gotten a 0-minute solve, but just because it took so long to submit, see if submit wasn't working, like, then it just didn't happen. Okay. Oh, I mean, let's see what my standings is currently. Currently in 8th, but I have submitted to problem H. Wow, apparently I had a really good problem B. What was bad? I had a terrible problem E because I misread it so many times. Yeah. Anyway, I think I did all right in that contest. I'm going to go through and explain the problems now. I'm just assuming that I have solved this problem. I really hope this gets accepted. Anyway, let's go through them. The first few ones I won't go through in that much detail. Like, this one is just implemented. So I literally just take in the 3 integers, sort them, take the 2 largest one, and if the sum is greater than 10, I print yes, otherwise I print no. So I'm not going to waste too much time on these ones. Like, this one's pretty similar. Again, I have a list of people. I guess I have the list of responses with at most 10 words. So for each response, if it has at most 10 words, I add it to the set. And I specifically put the quality first and then the index. That way I can just look up the maximum of all responses. And because in tuples, it will tie break by the first element. So when finding the maximum element, it will look at the first element and prioritize that before the second. So I want to prioritize the quality rather than the index. And then, so I get the relevant response and then I output the index and that's it. This problem, it's actually good enough just to loop through all cells in this order, and if it's not a dot, add it to the answer. My implementation is a little bit scuffed, but pretty much what I do is for all columns, for each column in order from left to right, I kind of get the sequence of characters going down, but I only look at characters that aren't dots, and then I add that to my answer. Pretty self-explanatory, hopefully. Accepted, nice. Rank 6. Looks like rank 6, but people might jump ahead of me. If I just not done this problem so badly, I might have had a chance at winning. But that's alright. Okay, problem D. Essentially, if you want to minimize the difficulty between 2 consecutive problems, you should arrange them in sorted order. Like, there's no point of having, where is it? There's no point of having problems like in the order 2, 1, 4, because 1, 2, 4 would be better, because that minimizes, I guess, the difference between adjacent ones. So the idea is, like, imagine you sort the array. So you have, like, for example, here, you kind of want to take the longest subarray that works. So for example, this subarray works because the difference between each adjacent one is at most 1. But this subarray doesn't work because this distance is too big. So in order to find the biggest subarray, I kind of just iterate through the sorted list. So I sort it first, sort the array first, and then I process it in order. And I kind of maintain a streak of the longest subarray, the length of the longest current subarray that works. So when I process a new element, if the distance between the previous element is less than or equal to k, I can sort of increase my streak by 1. So for example, if I've processed the 4 and the 5, when I process the 6, the 6 can go directly after the 5. So I kind of increase the streak by 1. But for example, if I was transitioning from the 1 and the 2 and I was adding on the 4, the 4 is too far away from the 2, so I have to reset my streak to 1. And then I guess the maximum of the streak, is the longest possible subarray which can be left, and then n minus res is the amounts that you have to delete. Hopefully that made sense. Okay, problem E is the problem which I misread the longest because I didn't understand the input. I didn't realize that. Okay, for some reason I thought the cardboard was just the border. I didn't realize it was the entire square. So I was doing something a little bit weird. But essentially, like, we can actually, like, I solved this with binary search, but this isn't necessary at all. Like, my solution is, I guess for a given width called mid, if you kind of sum this value up for all pictures, that is the total amount of cardboard. It's like, this would be the side length of the big square, the middle square plus 2 times the width. And if you square that and sum that up for all pictures, that's the total amount of cardboard. I just note that as W increases, the amount of cardboard increases. So if I want to find out whether the amount of cardboard is exactly C, then I can just binary search using this value. So that's what my solution does. But you can actually just solve this directly with equations. I believe it reduces to a quadratic. Like if you just call this variable W, then I guess the total area is just like SI plus 2W all squared. And if you kind of sum that up, that kind of leaves you with a quadratic, and then you can just solve the quadratic. But I didn't want to do maths. It cost me so much time because I misread that problem. If I'd done it in a different order, it would have been better. Okay, problem F. Problem F is, like, my solution is essentially, for each frog, I just mark the, I mark the coordinates it passes through, but I do one optimization. If there's multiple frogs with the same length hop, then I'll process them all simultaneously. So for example, if there's 3 frogs that all hop with a distance of 2, then I treat it as if only one frog jumps, but instead of, I guess, increasing, I guess, the number of frogs passing through that coordinate by 1, I'll just increase it by the number of frogs I'm processing currently. And simply, like, what this does right here is just kind of, it reads in the array, creates like a frequency array, and then I guess for each hop distance and number of frogs, it will iterate through the spots that the frog will jump through and increase that number by j, which is the number of frogs I'm processing. And then the maximum of those elements is the answer. I guess the reason this works is because of the harmonic sum. So this loop here only runs like n over I times. And you can prove that, I guess, the sum, if you add n over 1 plus n over 2 plus n over 3 all the way up to n over n, this is the harmonic series sum, and this is actually order n log n, and this is why this actually runs fast. Because if I process every single frog individually, this could be up to n squared, but because I process, I guess, frogs with hop distance at most 1, like if I process at most 1 batch of frogs with a distance of 1, at most 1 batch of frogs with a hop distance of 2, and so on, which means that I guess my complexity is bounded by n log n, and that's good enough. Problem G. Okay, problem G just uses a trick that, I guess, 2 coordinates are on the same like diagonal if and only if the sum, like, I guess 2 points AB and CD are on the same diagonal, I guess, if and only if A plus B equals C plus D. And yeah, so that's like, if you imagine, like, where's an example? This isn't giving me very good examples, but for example, if we had the stars at 0, 0, and 2, -2, I guess one of them would be northwest from each other. So this is like the northwest southeast diagonal. And because there's kind of diagonals in 2 directions, there's diagonals and anti-diagonals. Like for example, if I plot x plus y equals some constant for any given constant, you can see, like, for any given number of a, I guess the set of all points with the same sum forms some diagonal. And similarly, the set of points, if you take x minus a, it kind of gives the anti-diagonal. We can, applying this to this problem, 2 points are southwest / northeast to each other. If I guess x minus y is the same for both points. And they will be northwest / southeast of each other if their sum of their coordinates are the same. And obviously, there will be east-west if they have the same y coordinate and the same north-south if they have the same x coordinate. So all I do here is I kind of just keep track of 4 dictionaries. For each point, I look up how many points, like if this was the start, how many points are in one of the 8 compass directions from it, and do this just by querying the 4 dictionaries or maps with, x coordinate, y coordinate, the sum to handle diagonals, and the difference to handle anti-diagonals. And I increment 1 to each of those maps. And then I need to multiply it by 2 because, I guess if you think about it, you'll see that I've only counted half of them things. Because for each pair of points that are compass directions from each other, I would have only counted that pair once, whereas I should actually count them twice because either of them could be the compass and either of them could be the star. Okay, hopefully that made sense. Okay, problem H is interesting, but I've seen this similar ideas before. I guess the main idea is we can sort of create a graph. We have some implications. Each edge, actually we can just use these edges. I guess the question is, can we assign a value to each of n elements such that I guess the difference between AI and BI is exactly DI? And what we can do is imagine we have the edges 0, let's say we have these edges. Maybe an edge 0, 1, 4, and 1, 2, 5, and 1, 3, negative 2. Let's just, if we just assume that, I guess, oh, why did I, sorry, let me on one instead. Okay, let's assume that, I guess, soldier 1 is at camp 0, then because if I know that soldier 1 is at camp 0, then I know that soldier 2 is at camp 4 because I can use this implication. I now know that soldier 3 is at camp 9 because of this implication. I know that soldier 4 is at camp 2 because of this implication. And you can see that if you consider these first 2 as edges in a graph, if I know the camp of one of the soldiers, then I also know the positions of every soldier in that soldier's connected component. What I mean, for example, if I know the position of soldier 2, it's possible for me to work out the position of every other soldier. But if I have 5, 6, for example, then knowing the location of soldier 2 doesn't tell me anything about the location of soldiers 5 and 6, because if you kind of imagine the graph of these implications, there's a graph with edge from 1 to 2, between 1 and 2, there's a graph with edges between 2 and 3, and so on. If you consider that graph, I guess 5 and 6 form a different connected component to these ones. And so I guess the position of these soldiers can't imply anything about the positions of these soldiers. So what is actually good enough is just to construct this graph, and I guess just for each connected component, arbitrarily assign one of the soldiers to camp 0, and just do a DFS to see where all of the other soldiers in that connected component end up. And then we just check our answer. We just check all the implications, and if they all work, then the answer is yes, and otherwise the answer is no. For example, if there was, if there was something like this, if we assumed that soldier 1 was at camp 0, we could work out that soldier 2 is at camp 4. Knowing that soldier 2 is at camp 4 would mean that soldier 3 is at camp 9, but I guess the last implication doesn't check out with 0 and 9, and therefore this is impossible. So yeah, hopefully that makes sense. If it doesn't, then write something in the comments and I'll do my best to answer it. Anyway, I guess the standings should have settled by now, and looks like I ended up in 7th place. So I'll take that. Not too bad. Okay, thank you very much for watching. See you next time.